Welcome to Chapter 10, Nonparametric Tests. This video content is based on Essentials of Biostatistics in Public Health by Lisa M. Sullivan. In previous chapters, we focused on parametric tests like the t-test and ANOVA. These methods assume that data are normally distributed and measured on a continuous scale. But what if our data are skewed, ordinal, or the sample size is small? That's where nonparametric tests come in. First is Introduction to Nonparametric Testing. Nonparametric tests do not assume normality. They are often based on ranks rather than raw data values. They're ideal for ordinal data, skewed distributions, small sample sizes. These tests may be slightly less powerful than parametric methods when the assumptions of the parametric tests are met, but they offer robustness and flexibility when those assumptions are violated. Second is tests with two independent samples. The most common nonparametric test for two independent samples is the Mann Whitney U test, also called the Wilcoxon rank sum test. It's used instead of the independent samples t-test when the outcome is skewed ordinal, or when we cannot assume equal variances. We rank all the values across both groups together. Then we calculate the sum of the ranks in each group. The test statistic is based on comparing these rank sums. It tests whether the two groups come from the same distribution, or if one tends to have higher or lower values. Third is tests with matched samples. For matched or paired data, we use the Wilcoxon signed rank test. It's the nonparametric alternative to the paired t-test. We first compute the difference between each pair. Then we rank the absolute values of the differences, assigning signs based on whether the difference was positive or negative. Then we sum the signed ranks and compare to a reference distribution to get the p-value. This test tells us whether there's a consistent direction of change across pairs. Fourth is tests with more than two independent samples. To compare more than two independent groups using nonparametric methods, we use the Kruskal-Wallis test. It's the alternative to ANOVA when the data are not normally distributed or are ordinal. We rank all the data across all groups. Then we calculate the average rank for each group. The test statistic compares the variability between group ranks to the variability within group ranks. If the Kruskal-Wallis test is significant, we can conclude that at least one group differs, but it doesn't tell us which ones. We need follow-up tests to explore those differences. Nonparametric tests are essential when parametric assumptions don't hold. They offer a flexible, robust way to analyze skewed data, ordinal data, small sample sizes. We covered three key tests: the Mann Whitney U test for two independent samples, the Wilcoxon signed rank test for paired data, the Kruskal-Wallis test for comparing three or more groups. Each of these uses ranks instead of raw data, making them reliable even under non-ideal conditions. This concludes Chapter 10, Nonparametric Tests. In the next chapter, we explore more specialized methods for categorical data and survival analysis. This video content is based on Essentials of Biostatistics in Public Health by Lisa M. Sullivan.